Okay, so my name is Bilal, and today we'll be solving additional mathematics session May June year 2023, paper 1 and variant 1 2. Moving on, before starting, I want to say that please do like, share, and subscribe our channel. So we'll be starting with question 1, where the diagram shows the graph of y is equals to a cos bx plus c. Find the values of the constant a, b, and c. We need the values of a, b, and c. Now, for the value of a, what we can do is calculate the distance between these 2 points. This is the maximum point and this is the minimum point. So this would be 2, negative 6. This would be 8. And for amplitude, we need to divide the maximum and minimum point by 2. So we're getting this as 4. We have our A as 4. So basically, it's going 4 units upwards and 4 units downwards. It's going 4 units downwards from here and 4 units upwards from here. Now, for B, what we can do is have a look at the graph. So this is basically half wave of cos. If you look at it carefully, this is basically half wave of cos, which is if we plot cos x, this points to 180 degrees. But in our graph, it's basically 480 degrees. So we need to write this as the original graph is 180, and here we are given with 480. So we get solving and getting the ratio, so we'll be getting it as 6 3s are 18 and 6 8s are 48. So this would be 3 over 8. We have our B as 3 over 8. Now for C, we need to know where it starts from. So this is where it starts from. It goes 4 units upwards and 4 units downwards from here. So this is basically our origin point, or what you can say is the point where the curve starts. So our C would be -2. Where is our B? Again, so we are done with this question. Moving on to question 2, where it states do not use a calculator in this question. Now we need to solve the equation 2 plus root 5 x squared is equals to 4x plus 3 2 minus root 5. What we can do is, let's bring all these things to the left hand side. So this would be 2 plus root 5 x squared negative 4x negative 3 2 minus root 5. This is whole plus 3 and this would go over there, so this would be negative 3. This is equals to 0. The answer is required in this form, so we need to make sure that we have this answer. So we'll be solving this by using quadratic formula. Using quadratic formula, where A is equals to 2 plus root 5, our B is negative 4, and our C is negative 3 2 minus negative root 5. This is our A, B, and C. Let's plug in the formula minus B plus minus root B squared minus 4AC over 2A. We'll be plugging in all the values over here, so we'll get our answer as 4 plus minus 4 squared is basically 16, negative 4, negative 3, 2 minus root 5, then we have 2 plus root 5. This is whole, and this would be 2 then 2 plus root 5. Now moving on, we have this value as 4 plus minus. What we can do is apply a squared minus b squared over here. So this would be 4, 2 squared is 4, and then root 5 whole squared is 5. So this would be negative 5. We get our answer as 16 minus this 4 and minus 3 would be positive 3, and then this one would be multiplied. So this would be negative 12 over 2 multiplied by 2 plus root 5. Now further solving, we'll get our answer as 4. This would be plus minus 2. This would be 2 plus root 5. Since this would be 4 and root 4 is basically 2. So finally we take 2 as common over here. This would be 2 plus minus 1. 2 over 2 plus root 5. 2 and 2 would be cancelled out. We'll be solving these two. So this would be 3 over 2 plus root 5 and 1 over 2 plus root 5. We shouldn't have anything in the rational in the denominator, so we'll be multiplying it by 2 negative root 5 and 2 negative root 5 in both the denominator and the numerator. So this would be 2 squared would be 4, and then minus 5 would be negative 1, and we'll get our answer here as 6 negative 3 root 5. So this minus will be multiplied over here, and this will be getting our answer as negative 6 plus 3 root 5, and here we'll get our answer as negative 1 over, it would be the same, and this would be 2 negative root 5. This one would be multiplied over here, and we'll be getting our answer as negative 2 plus root 5. So we have our two answers as this. Now moving on to question 3. We are given the diagram shows the graph of y is equals to modulus of f of x, where f of x is a cubic polynomial. Find and factorize from the possible expressions for f of x. Here we are required to calculate the function f of x. So this would be, we have our roots as x minus 2, x equals to 1, and x equals to 4. Let's write it down. This would be x equals to negative 2, x equals to 1, x equals to 4. Now let's make an equation. This would be x plus 2, x minus 1, this would be x minus 4. So we have our three roots. We're multiplying all of them. We're getting our answer as this. But we need to know that is this the right answer? We have our where when x equals to 0. We'll be checking it by plugging in x equals to 0. So we get our answer as 2, negative 1, negative 4. We get it as 8. But it was 24 basically. So this function is basically multiplied by 3. But since it has modulus, so it can be either plus 3 or minus 3. Alright. So this is our final answer. Moving on to part B, which states solve the inequality. Modulus of 5x minus 2 is lesser than equals to 4x plus 1 modulus. So if we have modulus on both sides, we square both sides. So this would be 5x minus 2 whole squared lesser than equals to 4x plus 1 whole squared. So this would be 5x whole squared would be 25x squared minus 20x plus 4 lesser than equals to 16x squared plus 8x plus 1. All the things will go on the left hand side. So this would be 9x squared negative 28x and then positive 3 as lesser than equals to 0. Now by using calculator we can solve this equation and we will get our answers as 9 3s are 27. We can simply do this. This would be 27 and 1, so this would be negative 27 x and negative x, positive 3 lesser than equals to 0. This would be 9x x minus 3 minus 1 x minus 3, so then equals to 0. So this would be 9x minus 1, then x minus 3 is lesser than equals to 0. Now the function is basically lesser than equals to 0. Now if we revise the concept, we have our y equals to 0's line over here, and 1 over 9 is our root and 3 is our root. So our curve will look something like this. And the question asks for the values lesser than equals to 0. So lesser than equals to 0 is basically this part. So our range would be in between. We can write this as 1 over 9 and 3. So x should lie between 1 over 9 and 3. So we write it like this. Now moving on, we have our question 4, which is written as, in this question all lengths are in centimeters and all angles are in radians. Diagram shows a circle with center O and radius R. The points A and B lie on the circumference of the circle such that the angle AOB is theta. The length of the minor arc AB is 12. AB is 12. And the area of the minor sector is 57.6. The point C lies on the tangent to the curve, since it's a tangent and it's passing from the center, so this would be 90 degrees, such that OBC is a straight line. OBC is a straight line. Now it states find the value of R and theta. We'll be using all the things that are given in the question. That is, R theta is equals to 12, which we have as S is equals to R theta. This S is basically minor arc. So we have our one equation as R theta is equals to 12. Now we'll be using area of sectors equation, which is given as 1 over 2 R squared theta. Area of sector is given as 57.6. So this would be 57.6 1 over 2 R squared theta. Here we can simply plug in R theta over here. So this would be 12 into R divided by 2. So this would be 6, 57.6. And this 6 would be divided over there. So we'll be getting our R as simply 9.6. We can plug in this R over here. So this would be 9.6 theta equals to 12. Theta would be 1.25. So we have our R and we have our theta. Now moving on to part B, which is find the area of the shaded region, giving your answer correct to 1 decimal place. Now if you look at the question carefully, we need this area. We need this area basically. So for this area, what we can do is we can simply take the area of the triangle, this triangle, whole triangle, and subtract it from the sector, this sector. And if we subtract it, well, what we'll be getting is this area. Alright, and this was the required area. Alright, so we'll be going ahead and solving this. So our area of shaded region is basically area of triangle minus area of sector. This is basically given as 57.6. We need to calculate area of triangle, and for that we need the let's just remove this a little bit, and for that we need we have our this length, that can be base or height. We need this length. Now let's recall that we have this as 90 degrees. We have this our R as 9.6. We have this our theta as 1.25. What we can do is apply some trigonometric rules. This is basically opposite and this is basically the base. So opposite over base was tan. Tan 9.6 equals to AC is the opposite side and base is the 9.6 sides. So this would be AC, will have our AC as 28.89. Now plugging in this, so this would be 1 over 2. Our base was 12. Our height can be 28.89, and this would be subtracted by 57.6. Sorry, this was 9.6. It wasn't 12, it was 9.6. So this would be cancelled out, and this would be 2 4s are 8 and 1 4.8, and these two would be multiplied, then this would be subtracted from here. So we'll get our final answer as 81.1. So this is our final answer. Now moving on, we have our question 5, where it needs find the exact solution of the equation this So let's just simplify it a little bit. So this would look like 6p powered 1 over 3 negative 5 p powered 1 over 3 negative 13 equals to 0. What we can do is we can substitute p power 1 over 3 as x. So this would look like 6x minus 5 over x negative 13 equals to 0. What we can do is multiply the whole equation by x. So this would be 6x squared negative 13x negative 5 equals to 0. Now we need negative 30 factors. So this would be 2 and 15. So this would be 6x squared plus 2x negative 15x negative 5 equals to 0. We take 2x as common, we'll get as 3x plus 1 negative 5 3x plus 1 equals to 0. So this would be 2x minus 5 3x plus 1. We'll get our x as negative 1 over 3 and x as 5 over 2. Now let's remember this, let's recall this formula. We'll be doing it like this. So this was p powered 1 over 3 as negative 1 over 3. We'll be applying cube on both sides. So this would be 5 over 2 squared as well, cube it as well. So we'll get our final answer as minus 1 over 27, and this would be 125 over 8, I guess. 125 over 8. So these are our final answers. Now in part B, it states solve the equation this minus LGX plus 2 equals to 1, giving your answers in exact form. It needs the answer in exact form. So what we can do is apply the power law. So this would be going in the power. So this would be LG 2x plus 5 power 2 negative LG x plus 2 equals to 1. Here we can apply quotient law, where when the two logs are subtracted, this function gets divided. So this would be LG 2x plus 5 whole squared over x plus 2 equals to 1. Now this LG and 1 can be converted to 10 power 1, and this would be 2x plus 5 whole squared, and this would be over x plus 2. Now what we can do is just multiply this by 10. So this would look like 10x plus 20, and we will be simplifying this. So this would be 4x squared plus 20x plus 25. Now let's bring everything on the right hand side. So this would be 4x squared plus 10x plus 5 equals to 0. And here we can apply quadratic formula. I have already applied in the previous question. You can look at that, and here we'll be just simplifying this. So this would be negative 10 plus minus b squared would be 100 minus 4 into 4 is 16, 16 into 5 is 80 over 2 into a would be 4. So solving this, we'll be having our answer as minus 5 plus minus root 5 over 4. So this will be our final answer. Now moving on to question 6, where a part suggests given that cot square theta is equals to 1 over y plus 2 and sec theta is equals to x minus 4, find y in terms of x. Since it needs y in terms of x, we'll be solving this. So this would be 1 over cos theta is equals to x minus 4, and we can just substitute it this by this. Since sec theta is basically 1 over cos theta, so we'll be cross multiplying this, and we'll get our answer as 1 over x minus 4 equals to cos theta. Now let's remember cos theta is basically base over hypotenuse. So this is our base and this is our hypotenuse. Let's draw a triangle. So this would look something like this. Our hypotenuse is x minus 4 and our base is 1. We can use Pythagoras theorem to calculate our perpendicular side. So this would be x minus 4 whole squared and then negative 1. So we got our perpendicular side as well. Now what we can do is substitute it over here. So this would be cos squared theta over sine squared theta. Cot theta is basically cos theta over sine theta, and here it is squared. So this would be squared and this would be squared. and this would be 1 over y plus 2. What we can do is just cross multiply it. So this would be sine squared theta over cos squared theta y plus 2. Sine theta is basically this over this. So we have our answer as x minus 4 whole squared minus 1 over x minus 4 whole squared. And since it's divided, then we can inverse the cost relationship. That would be hypotenuse over base. So this would be x minus 4 whole squared. So this and this would cancel out, this and this would cancel out. We'll have our final answer as x minus 4 whole squared minus 1. This 2 would shift over there. This would be negative 2, and we'll have our final answer as x minus 4 whole squared. So we'll have our final answer as x minus 4 whole squared negative 3. So this is our final answer. Now moving on to part B, where it states solve the equation this for phi in between minus pi till pi, giving your answer in terms of pi. It needs the answer in terms of pi. So let's solve this. This would be root 3. Cosec is basically 1 over sine. So this would be sine 2 phi plus 3 pi by 4 equals to 2. Now what we can do is cross multiply. Here we can cross multiply. So this would be going over there, and this 2 would be coming down over here. So we'll have our final answers as root 3 over 2 sine 2 phi plus 3 pi by 4 equals to root 3 by 2. Now since sine is positive, we'll have our answers in first, second quadrant. Do make sure to keep this thing in mind. So this would be sine inverse root 3 over 2 phi plus 3 pi by 4. Now we'll have our alpha as pi by 3. So our thetas would look like pi by 3. Pi would be subtracted by pi by 3. Pi by 3 would be subtracted by pi. So we get our answer as 2 pi by 3. Now we can take second revolution as well, since it has 2 multiplied and this would be divided. So what we can do is take the second rotation as well. So 2 pi would be added in both the solutions. So this would be 7 pi by 3. This would be 7 pi by 3, and this would be 8 pi by 3. This would be 8 pi by 3. So we'll get our final answer. We'll be subtracting each and every. So we'll get our final answers as 2 phi plus 3 pi by 4 equals to 5 by 3, 2 pi by 3, 7 pi by 3, and 8 pi by 3. So what we will do is subtract 3 pi by 4 from each and everything and then divide it by 2. So we'll be getting our final answer as negative 5 pi by 4, 24, sorry, negative 1 over 24 pi, 19 pi by 24, and 23 pi by 24. So these are our final answers. Now moving on to question 7, which is find the number of ways in which 14 people can be put into 4 groups containing 2, 3, 4 and 5 people. So we have 14 people. We need to first make sure that they stay in the 2 groups. So this would be 14C2. Now we are left with 12 people. So this would be 14C3. We need to select 3 people. Then we are left with 9 people. We need to select 4 people. Then we are left with 5 people and we need to select the 5 people. So these would be multiplied and we'll get our answer as 2, 5, 2, 2, 5, 2, 0. Now moving on to part B. 6-digit numbers are to be formed using the digits these. Each digit may be used only once in 6-digit number. A 6-digit number must not start with a 0. This is understood. Find how many 6-digit numbers can be formed if there are no restrictions. So let's just place those dashes. So this is our 6-digit number. We can have 1 till 9 combinations over. So we have 9 combinations over. Now we can have 0 over here as well and the other 8 numbers. other 8 numbers. So we'll have our 9 combinations over here, 8 combination, then 6, 7, then 6, then 5. So we'll be multiplying and getting our answer as 9 multiplied by 9p5. So this would be 136080. This is our final answer. The 6-digit number is divisible by 10. For the number to be divisible by 10, it needs to have 0 at the end. So we'll have our 1 till 9 combinations over here, 8 combinations over here, 7 over here, 6 over here, and 5 over here. So this would basically be 9p5, and this is 15120. We have our part 3 as the 6-digit number is greater than 5000 and even. So we'll be solving 3 cases over here. Case 1 is basically we have our 6 at the end. Sorry, 6 at the start. We have 6 at the start, 8, 7, 6, 5, and we can't have 6 at the end. So if we have 6 at the start, we can't have 6 at the end. We have only 4 combinations over here. So we have 4 combinations over here, and these 2 are since selected. Then we'll have our 8 combination, 7, 6, and 5. These are not the combination. This is the fixed number. Say, is it okay? So we'll be solving the case 2. That would be where we'll be starting with 8, placing those 4 dashes, and then we'll have our 4 combination again. So those 4 combinations would be 0, 2, 4, and 6. So these are 4 combinations. This is only a single combination. We'll have our 8, 7, 6, 5, and 4. We'll have our case 3 as 6 and 8 both are available over here. So we'll have our values here as 5, 7, and 9. We can have 5, 7, or 9 over here. And we can have all the 5 combinations over here, that is 0, 2, 4, 6, and then 8. So we have 5 combinations over here. We'll have 3 combinations over here. We'll have 8, 7, 6, and then 5. By solving and then multiplying, by solving or multiplying this, we'll get our answer as 25200. Here if we solve this, we'll get our answer as 6720, and this would be the same since this is simply same. We'll be adding all these 3 possibilities, and we're getting our answer as 38640. Now moving on to question 8, it is given that f of x is this. Write down the least possible value of a. So it needs the least possible value of a. What we can do is we can simply equate this to 0. So this would be 3x minus, since ln can't be in negative. So 3x, we can equate it to 0. 3x minus 4 is equals to 0. And this would look like x equals to 4 over 3. So x should be 4 over 3. X should be greater than 4 over 3. So our a is 4 over 3 basically. Write down the range of f. We need the range of f. If we look at it carefully, this can go in negative and positive anywhere. So this would look like negative infinity till positive infinity. So we will have a range as negative infinity and positive infinity. Alright, or we can write it as f is equals to, this belongs to real number, positive and negative both. Now we need to draw a graph of f of x and f inverse of x. So for f of x, we have a range as 4 over 3. It should be greater than 4 over 3. Let's draw a rough graph. This is 1, this is 2, this is 3, this is 4, this is 5, this is 1, this is 2, this is 3, this is 4, and this is 5. You can take it as 1 over 3, 2 over 3, 3 over 3 is basically 1. This is 4 over 3. Alright, we can do the same over here. This is 1, 2, 3, 4, and then 5. So this is basically 1 over 3, 2 over 3, 1, and then 4 over 3. We have given this, we are given with this negative, negative, negative 1 over 3, negative 2 over 3, 1, negative 4 over 3. So we are given with this. Now, here x should be greater than 4 over 3. So x should be greater than 4 over 3. We have our x is like this. x equals to 4 over 3 is this. If x is greater than 4 over 3, and we'll have our, what we can do is, what we'll have our x is 4 greater than 4 over 3. So our graph would start at this point, something like this. We can calculate our y as well, but it won't be recommended. We can use y equal to 0 is equals to 2 ln 3x minus 4. This would be going in power, so this will have our e powered 0, that is 1, equals to 3x minus 4 whole squared. This is e powered 0. E powered 0 is basically 1. 1 square root is plus minus 4, so this would be 3x minus 4, and we get our answer as 5 over 3. So we have our 5 over 3. So we have correctly plotted it. Now what we can do is plot the f inverse of x. What we can do over here is, let's just place a line over here, because the domain of f of x becomes the range of f of x. So the line of f inverse of x wouldn't be touching this. Alright, the line of f of x f inverse of x wouldn't be touching this line. So what we will do is, and it can be negative, this and negative, the other thing. What we can do is, let's just take the, this would be 2 and this would be 2 again. So we'll have our point of intersection at 2 and 2. This would be basically, let's draw a rough graph of f of x, f inverse of x. So this would be something like this. Let's calculate the f inverse of x. F inverse of x would look like, f inverse of x would look like 2 ln 3x minus 4 equals to y. So this would be e powered y equals to 3x minus 4 whole squared. This would be e powered 1 over 2y plus 4 over 3 equals to x, and this x can be substituted. Let's take some values. What we can do is take 5 over 3 value, that would be e powered 5 over 3 multiplied by 1 over 2 plus 4 divided by 3 is basically 2.1. So this is basically 2.1. 5 over 3 is 2.1. So basically over there. Some mistake over here. Acha. Okay. So it has to be greater than 4 over 3. Since it has to be greater than 4 over 3, so this would be 5 over 3 as 2.1 something over here. So this would look something like this. Do is simply draw this line, and this would be, they would be just getting intersected at the next point, next 2 points. You do not need to solve this using your answer to part B. Sketch the graph of this on the axis below, showing the coordinates of the point where we are done with the question. So this is the rough graph. I have drawn the enlarged image. You should be drawing the lesser enlarged image to get the final solution. So it is given that g of x is equals to 2x minus 3, where x is greater than equals to 3. Find an expression for g of x. So we need to plug in x as 2x minus 3. So this would be 2 multiplied by 2x minus 3 minus 3. We get our final answer as 4x minus 6 minus 3, and this is 4x minus 9. Part 2 is hence solve the equation f of g of x equals to 4, giving your answer in exact form. So this would be 2, we have our g of x, and we have our f of x as this. So we'll be applying g of x over here. So that would be 2 ln 3 4x minus 9, and then negative 4 equals to, is given as equals to 4. This would be ln 12x minus 27 minus 4. This 2 would be divided over there, so this would be equal to 2. We get our final answer as, we remove the ln and make this as power of e. So this would be 12x minus 31, and we'll be getting our answer as e power 2 positive 31, and then divided by 12 to get our final answer. Now moving on to question 9, where we have a curve and a line. The diagram shows part of the curve this and the straight line. Find the area of the shaded region, giving in your answer in the exact form. Now if you look at it carefully, we have this area under this curve till this point, and if we remove the area under this line, we get our final area, final shaded region, that is something like this. Alright, so what we'll be doing is subtracting the lines area from the curves area. So now moving on, before we start, we'll be calculating the point of intersection over here. So this would be, so this would look like, substituting, we have our equation 1 as 3y equals to 2x plus 6, and our second equation as y equals to 3 plus 4 over 2x plus 1. Now what we can do is substitute this equation 2 into equation 1. So this would look like 3 multiplied by 3 plus 4 into 2x plus 1 equals to 2x plus 6. We'll be solving this to get 9 plus 12 over 2x plus 1 equals to 2x plus 6. We'll be multiplying 2x plus 1 by whole equation. We're getting our answer as 18x plus 9. This 12 can go over there. So this would be 4x squared plus 2x plus 12x plus 6 minus 12. So we move each and everything on the right hand side. We get our final answer as 4x squared minus 4x minus 15 equals to 0. We'll be solving this equation over here. This would be 4x squared plus 6x minus 10x. This is our negative 60s, what we call factors. This is 6 and 10. So we'll be taking 2x as common. We'll get 2x plus 3 over here. Then negative 5 common. We'll get our 2x plus 3 again. This would be 2x minus 5 and 2x plus 3. So we get our answers as x equals to 5 over 2 and x equals to negative 3 over 2. We'll be rejecting this since we needed a positive direction. So this is our final answer. This is rejected. So we have our x as 5 over 2. Now remember what we concluded was we need to take the limits of 5 over 2 till 0, since this point of intersection is 5 over 2 till 0, and we need to subtract the lower line from the upper curve. So this would be, let's write both equations. So this would be 3 plus 4 over 2x plus 1 negative, and 5 over 2 0, 2x plus 6 over 3. We have simply divided the equation by 3 to get the answer in x terms and make the y as subject. So this would be integrated and we'll get our answer as 3x plus, and this would be in ln, and we have our differentiation as 2, so this would look like 2 ln 2x plus 1. Since we had 2 extra over here, we are applying the limits 5 over 2 and 0. And here, if we integrate it, we get our answer as 1 over 3 x squared plus 6x. We are applying 5 over 2 and 0's limit over here. We get our final answer as 15 over 2 plus 2 ln. 5 over 2 multiplied by 2 is 5 plus 1 ln 6. This would be ln 6. Then this would be 0 and this would be 0. So this would be 0. This is the upper, this is the curves part, and this would be the lines part. This would be negative 1 over 3, 5 over 2 whole squared plus 6, 5 over 2. So this would be, here this would be finally written as 7.5 plus ln 36. This would go in the power, and this would be negative 25 over 12. Since this is 25 and 4, this would be 4, 2 power 2 is 4, and then multiplied by 3, this would be 12, and this would be negative 5. Since this would be cancelled out and this would be cancelled out, this would be multiplied by negative, so this we'll be getting our answer as this. We're solving these and this one, and this one by calculator, we'll be getting our answer as 5 over 12 plus ln 36, and this is our final answer. Alright, now moving on, we have our question 10 as the first three terms of arithmetic progression are this, where x should not be equals to negative 1 over 2 because it will make it 0. So that the sum to n terms can be written in the form this, where a and b are the integers to be found. So for n terms sum, we can write it as n over 2, 2 multiplied by a plus n minus 1 d. Now we have our n as n, the n would remain as n. We have our a as 2x plus 1. We can calculate the difference at first. That would be term 2 minus term 1. Our term 2 was 4 into 2x plus 1. We can just simplify it and write it. So this would be 8x plus 4, and this would be subtracted by minus 2x and minus 1. So we get our difference as 6x plus 3. So this would be n minus 1 and 6x plus 3. So taking 2 as common to cancel, taking 2x plus 1 as common to get it something like this. So this would be n over 2, 2x plus 1 is taken common. So we'll have, what we have over is here is 2 plus, this would be left with 3, n minus 1. So we'll write our final answer as something 3n, and then this minus 3 plus 2 would be minus 1, and we'll get our answer as 3n minus 1. So this is our final answer. Our a would be 3 and our b would be negative 1. Given that sum to n terms is basically this. Sum to n terms was previously calculated, n over 2, 2x plus 1, 3n minus 1. This is equals to 54n plus 37, and this is multiplied by 2x plus 1. This 2x plus 1 and 2x plus 1 can be cancelled out. We'll get our answers as 54n would be multiplied by 2, so this would be 108n minus 74, and this would be multiplied, so we'll be getting our answer as 3n squared minus n. We'll bring all the things on the left hand side, so this would be 3n squared, negative n, negative 108n, positive 74 equals to 0. This would be positive 74 since it is multiplied by 37. And by solving this, we'll get our answer as 3n squared, negative 109 and negative 74. Now we can plug this in the calculator and we'll get our answer as n is equals to 37 only. Alright, since n can't be negative. Given also that the sum to n terms in part 2 is equal to 1017.5, find the value of x. Now sum to n terms is given as 1017.5. In part 2, this was the equation. So we have our 54n, our n was given as 37 plus 37 multiplied by 2x plus 1 is basically 1017.5. So this, let's just calculate it. Write it again. 1017.5. Let's just calculate this part. We get our this part as 4 multiplied by 37 and plus 37 is 2035. 1017.5 is divided by 2035 and then subtracted by 1 and 10 divided by 2. So this is basically 1017.5 divided by 2035. This would be subtracted by 1 and multiplied by 2. So this would be basically, I guess, did I make some mistake over here? No. So this was 54 multiplied by 37 plus 37 is basically 2035 and 1017.5 divided by 2035 is 1 over 2 and we have our 2x plus 1 as this, so this would be subtracted by 1 and then multiplied by, sorry, divided by 2. We'll be dividing it by 2. My mistake over here. We'll be dividing it by 2 since 2x is multiplied, so this will be divided by 2. So we'll be having our final answer of x as negative 1 over 4. Now moving on, we have our part B as the first three terms of a geometric progression are 2y plus 1, comma 3 into 2y plus 1 whole squared and 9 2y plus 1 whole cube, where y is not equals to negative 1 over 2. Given that nth term of the progression is equal to 4 times the n plus 2th term, find the possible values of y, giving your answer as fraction. Now let's first calculate the common ratio. We'll have our common ratio as term 2 divided by term 1. That would be 3 2y plus 1 whole squared and then 2y plus 1. We cancel it out and we're getting our common ratio as 3 into 2y plus 1. So now let's just apply this thing. So this would be nth term. We can write our nth term as Tn is equals to a power n minus 1. So we have our a as 2y plus 1. We have our r as 3 into 2y plus 1 powered n minus 1. Sorry, this would be, yes. So this would be n minus 1. And we have our this as 4. This would be multiplied by 4 times and n plus 2 term would be written. This would be 2y plus 1, 3, 2y plus 1 powered n plus 2 minus 1. This would be n minus 1. So what we'll do, what we have is we'll be dividing both these. So we'll be getting, this will be cancelled out and this 4 will go over there and this would go over there. So this would be 1 over 4, 3, 2y plus 1 whole powered n plus 1 and this is 3 2y plus 1 whole powered n minus 1. So we have a difference of power 2 over here, right? And if we move this up, we'll be getting our answer as 3 2y plus 1 powered 2 whole power 2 and this would be 1 over 4. We can take the power of 3 and then multiply it over there. So this would be 3 squared would be 9 and 1 over 4 would be 1 over 36 equals to 2y plus 1 whole squared. And then what we can do is add our square root to both sides. So this would be plus minus negative 1 over 6. This would be 2y plus 1. And what we can do is we can subtract 1 over 6, subtract 1 from this part and then divided by 2. So this would be our final answer. Our final answers would look like y is equals to negative 5 over 2, 12 and negative 7 over 12. Now moving on to part C, which is given as the first three terms of a different geometric progression are sine theta, 2 sine cube theta and 5 sine cube theta for theta lies in between 0 till pi by 2. Let's just first calculate the common ratio. That would be sine theta, sorry, term 2 divided by term 1, that is 2 sine cubed theta over sine theta. This would be cancelled out, so that we'll get our common ratio as 2 sine squared theta. Now we need to calculate the sum to infinity. Our sum to infinity looks like a over 1 minus r. We have our a as sine theta, we have our r as 1 minus 2, sorry, 2 sine squared theta. So this would look something like this. And the sum to infinity to exist, it shouldn't be 0, this shouldn't be equal to 0, and this shouldn't be equal to 0. Because if this is 0, sum to infinity would be 0. And if this is 0, sum to infinity would be infinity, which means that doesn't exist. So we'll write it as sine theta equals to 0. So theta would be 0 and 1 minus 2 sine squared theta as 0. So this would be 1 over 2 sine squared theta. Let's just move this over the next page. So this would be plus minus root 2 sine theta. And if we solve this, we'll get a, since it is in the first quadrant only, so we'll be using plus root 1 over 2, so that would be sine inverse plus root 1 over 2. We get our theta as pi by 4. So theta will lie in between 0 and pi by 4. How we can write this as? We can write this as 0 till pi by 4. So this is our final answer. Thank you for watching.